Hello, everyone, and welcome to this CGHE webinar, which is the third in the series on artificial intelligence in higher education. This is really an exciting and timely series, which covers 6 webinars altogether, with excellent speakers on various aspects of AI in the sector. My name is Janja Komljenovic from Lancaster University. I've put this series together. And today we will be hearing from Carlo Perrotta on interrogating AI and how it all functions. Carlo is an associate professor of digital education at the University of Melbourne. Welcome, Carlo. We are really grateful that you are here, especially with the differences in the time zone. But before I hand over to Carlo, there are some brief housekeeping points to mention. So this webinar is being recorded and it will be posted online on our website as soon as we can manage. A transcript of the chat function conversation will also be posted. We normally also post on our YouTube channel. Also, please keep yourself muted during the talk. And then after the talk in the Q&A session, if you will want to ask a question and I will call on you, then please unmute yourself as you speak. There's no need to have your video on during the webinar, but please do so when asking a question. We recommend that you use the speaker view so you can more clearly see who is talking. And to ask a question, just use the chat function throughout the webinar so you can start posting questions and comments immediately. At the end of the presentation, when Carlo finishes with his talk, I will prepare a sort of speakers list for the questions. And if your question is selected, then I will invite you to unmute yourself, switch on your video if you want, and ask your question yourself. Okay, I will now stop and pass over to Carlo.
Yes, thank you very much, Janja, for the introduction, and it's a great pleasure to be here. It's a great honor. I'm going to start sharing my slides now, so we can begin. Like Janja said, feel free to put your questions in the chat as I talk. Okay. So I'm sharing my screen now, and you should be seeing my slides. Janja, can you just give me a quick thumbs up if you can see it? Fantastic. Okay, so thank you everyone for being here. Like Janja said, my name is Carlo. I'm an associate professor at the University of Melbourne. And today I'm going to be talking about my work in artificial intelligence, especially the sort of kind of approach that I've been experimenting with to interrogate artificial intelligence in education. So my research, broadly speaking, is concerned with the platformization of education. And the assumption that underpins my work, a great deal of my work, is that we cannot understand platformization without examining the role of artificial intelligence in education. So, we have been talking about artificial intelligence in education for quite some time now, in this sector. But I still feel that it's necessary to begin with a bit of a historical background, which I think will help set a bit the tone of the session. And this kind of historical background is also important because I think it helps convey a very important principle of contemporary AI, which is the fact that brute force won. So I'm gonna explain that. We all know, many of us have heard about the kind of cycles of boom and bust of artificial intelligence, the fact that it had a bit of a checkered history, with AI winters and all that. So if we, for example, consider 1950, more or less, when Alan Turing introduced his test, his eponymous test to distinguish between an artificial and a human agent as the birth year of modern artificial intelligence, Then the first backlash took place actually shortly after that, when symbolic AI emerged with the first AI program, which was called Logic Theorist, and was developed in 1956 by two of the founding fathers of the field, who were very much inspired by Alan Turing, Alan Newell and Herbert Simon. And this program, Logic Theorist, was designed to act like a mathematician, using branching deductive trees and rules of thumb, so heuristics, to prove mathematical theorems. So despite its achievements, the program failed to enthuse fellow researchers and founders. And this led to the first winter, as they called it, of artificial intelligence. However, this was not a complete stop, but just a pause in research activity, which resumed several years later, and culminated actually around the 1970s, and then the early 1980s, with the development of expert systems. These expert systems tried to replicate human expertise by applying a procedural logic based on conditional branching, mostly not if-then, the classic kind of conditional logic of early kind of AI paradigms. And this kind of approach was then used to provide guidance in the context of specific handcrafted knowledge domains designed in collaboration with human experts. Again, this particular form of AI was a direct evolution of the symbolic approach, and it built on several ideas about mental representation and problem solving, which were introduced by logic theorists, nearly 30 years before that. So even though it was an evolution, it was a development, and it managed to achieve some significant results, it also faltered and led to a second AI winter, which lasted approximately another decade, until the current enthusiasm for machine learning, began to emerge around the mid-1990s. And this is when basically computational methods trained on large amounts of data began to emerge and to be used to automate tasks of classification, prediction, and communication. So one of the kind of AI gurus of modern AI, Richard Sutton, reflecting on this trajectory of artificial intelligence over the past 70 years or so, suggested something quite interesting. Basically, he was reflecting on these two distinct paradigms of artificial intelligence: the more conservative and tame approach that relies on knowledge representations, so human expertise is modeled and built into artificial agents, and the more aggressive brute force, as he called it, computational approach that relies on scale, and computation, so computational muscle, literally, and big data. So Richard Sutton is an interesting character. He's part of that kind of group of generation of AI gurus who are caught up in this narrative of the singularity and artificial intelligence soon replacing kind of humans. So he's an interesting character that, but aside from this kind of peculiarity, he managed to capture something quite important, I believe, in the dynamic of artificial intelligence, and the fact that this is the artificial intelligence, or the successes of artificial intelligence are often tinged with bitterness, as he put it, because they confirm systematically that a less refined and blunt approach is more effective than a human-centric one. And this bitterness was already apparent in one of the earliest and the most well-documented battlegrounds of artificial intelligence research, computer chess. And I put here this quote from a piece that he wrote a few years ago, which I think is worth quoting in full. He says that the methods that defeated the world champion Kasparov in 1997 were based on massive deep search. And at the time, this was looked upon with dismay by the majority of computer chess researchers who had pursued methods that leveraged human understanding of the spatial structure of chess. When a simpler search-based approach with special hardware and software proved vastly more effective, these human knowledge-based search researchers were not good losers. They said that brute force search may have won this time, but it was not a general strategy. And anyway, it was not how people play chess. These researchers wanted methods based on human input to win, and were disappointed when they did not. So it is true, Sutton is right in this regard, the trajectory of AI research, kind of proved the champions of human knowledge wrong over and over again, because in domain after domain, human-centric models that tried to valorize human expertise were outperformed by opaque statistical approaches that could quickly mobilize computational power and the growing, the vastness of the internet, or the data pool of the internet. And this came with a promise, the promise that statistical learning soon would be able to completely eliminate labor-intensive human expertise and reframe knowledge as a discovery, something that can be achieved inductively and indeed automatically from data, moving kind of from bottom up, from data, proxies, left behind traces, the things that have just found, collected in large amounts on the internet. And this would be a more efficient and performant route to knowledge, to truth. And this kind of is the promise that I believe encapsulates the moment in which we are right now in society and in education also. And it is certainly confirmed by what we are observing, for example, in the success of large language models, which had been built on exactly the premise and the promise that I outlined before. This idea of statistical learning, that benefits from the internet extracted trace data, and allows this model to reach unprecedented levels of performance, enabling them to replicate human communicative competence and creativity without any scientific or philosophical insight into the actual dynamics of human cognition. Yeah, and this kind of situation, this condition in which we're in, is being sort of criticized by many people, like Mark Andreevich, who talks about this condition as an inductivist fallacy or a fantasy. The idea that it is possible to achieve some kind of fully formed, unfettered, one-to-one sort of digital informational trove where the entirety of the human experience has been captured by all-powerful machines. This is how we put it. So obviously the twist in all this story is that human judgment and inference and experience have not been replaced or eliminated, but they've simply been relegated in the background. So biases still creep in these systems, through the domain knowledge assumptions and kind of computational and statistical conventions that inform the various operations, that are involved in model architecture, so encoding, feature engineering, the so-called human-in-the-loop operations. And in addition to that, the biases have an unavoidable influence on this model, alongside a number of undesirable kind of social factors, racism and sexism and other kind of structures that are reflected in these models. And the fact that these things cannot be avoided then calls for yet another framing structure, another sort of form of reliance on human intervention. But this time is not in the form of elite expertise, but in the form of a sprawling global network of underpaid workers who manually label data at training stage or moderate algorithmic content while remaining unseen in the background. So here we see basically the trajectory of artificial intelligence kind of unfolded over a period of 70 years, how it was accompanied by a certain rhetoric, by certain claims about the power of data, the power of algorithms, and how these claims were often partially kind of contradicted by a reality where basically human expertise, human intervention, human judgment, human inference have not been completely eliminated. They probably are not going to be eliminated, but they still enter into the picture in many often problematic ways. So these are the sort of things, the way the debate, the critical kind of debate around artificial intelligence broadly and in education is unfolding. And the question that interests me and the question that I want to explore today is what sort of empirical work can justify such claims? What sort of empirical work allows us to interrogate critically artificial intelligence and make claims that can contradict, that can sort of act as a counterpoint, right, to some of these narratives and these ideas that are becoming increasingly hegemonic, increasingly dominant. So that question then brings me to I suppose the main argument, the main point that I want to explore in this session, which is the idea that it is possible to undertake an empirical analysis of artificial intelligence in education, and there are ways through which we can sort of interrogate these systems, and through which we can sort of develop interesting critical empirical accounts. Then obviously we can share with the broader academic community and broader society. A key notion that is part of this approach is this idea of sort of looking inside, peering inside the black box of algorithmic modeling. And this word in particular, this concept in particular, modeling, is crucial. Model is a technical term that refers to computational representations, abstractions of concepts, processes, and systems. The driving assumption here is that artificial intelligence is made possible by modeling the real world so that it can be controlled and predicted. And the process involves, of course, the use of mathematical formalizations and data to simulate a phenomenon of interest. And the list of phenomena that can be modeled, obviously, as we know just by a cursory look of what's happening around us, right? The list of phenomena can be modeled, runs the entire spectrum of organized sociality and includes casual and deeply involved interpersonal relations, consumption, employment, policing, welfare, health, and of course, multiple educational functions and activity, learning, teaching, assessment, administration, behavior management, in formal settings, and so forth. The way a model is developed is by imposing a grammar of action. This is a term that comes from Meyer in 1994, which, as I suppose the word suggests, it basically refers to a formalized set of symbolic representations that indeed acts as a grammar, and is kind of based on a computational logic that is designed to operate as a structure that guides basically what happens, the different kind of permutations that happen in a particular, in a modeled sort of a phenomenon. So the point here, the first point I want to make is that, engaging critically with this particular dynamic, with modeling, is important. It's an important element. It's an important aspect of this empirical project that I'm describing here. But the purpose of doing so is not to question the epistemological legitimacy of abstraction. There was a discussion a few years ago in education technology, basically between people in the sort of critical data studies camp and people in the learning analytics camp, and who were basically discussing the learning analytics, the field of learning analytics. And one of the topics, the sort of contention, was the issue of abstraction. And many people in the learning analytics community objected to the view that a critique of abstraction can be put forward in a way that does not undermine the argument. The idea is that it is not a question of undermining abstraction as a legitimate way of knowing. I think that kind of is besides the point, and kind of when the argument is framed along those lines, it kind of undermines the kind of critical project. The point of engaging with abstraction is to highlight, the purpose is to highlight how abstraction in modeling quickly becomes political and aligned with certain principles. Utility, efficiency, productivity, principles that embody a very partial vision, a very partial sort of understanding of how societies and by extension education should be governed. So that is the reason why I believe it's productive to critique abstraction, not as a mode of knowing, but as a mode of knowing that tends to align itself with a particular political sort of view of society. And by doing so, we can then open an interpretative window on that political alignment, and then we can say some more interesting things, empirically interesting things. Another angle on the same kind of premise is that of data infrastructure studies. Here the focus, the empirical focus, is on how power is materialized and enacted, in algorithms, in artificial intelligence, through technical specifications, development tools, official and unofficial computational standards. Things like application programming interfaces, APIs, are of particular interest in this sense, for the way they operate as a boundary resources, basically switches, plugs, located at strategic points between contexts, between groups, between users and developers, between platform owners and other actors. And by doing so, basically, they sort of regulate interactions across this kind of digitized, platformed context. And they regulate the flow of data, which is then channeled along multiple computational processes, goes into training, algorithms, artificial intelligence systems, predictive systems, and so on. So that is another kind of interesting angle, just by looking at how these practices come together materially, symbolically, the conventions, the standards that quite literally bring artificial intelligence into being. So, the key sort of methodological takeaways from this kind of approaches that I'm describing is that technical auditing, sort of interrogating artificial intelligence systems, algorithms, platforms, and kind of technical aspects, if you like, the nitty-gritty, if you want to call it, is definitely a productive exercise, but it's not the end goal. It's instrumental to something else. It paves the way to something else. It provides important insights into the often black boxed operations of artificial intelligence. but its main benefit lies elsewhere. It basically provides a rationale, it provides a springboard, I believe, for a more relational and political approach to research on these systems. So having peeked inside the black box, right, with a degree of systematicity and technical awareness, right, and that can be done from a non-specialist perspective. There are traditions in, for example, science and technology studies that kind of show that there are established kind of approaches, ethno-methodological, there are methods, there are sort of methodological conventions that can be mobilized to do that productively. So once we've done that, then we can sort of shift our gaze to what happens around the technical systems. So the sociological and cultural meanings that animate the data sets, the models, the APIs, and all the other materializations. The economic interests of the prediction and the automation industry, the sort of dynamics of the professional dynamics, this disciplinary kind of politics, if you like, of the data science and computer science communities as domains where, despite their objectivist aspirations asserted in their very name, it's not the fact that they call themselves sciences, right? Despite that, they are rife with uncertainties and controversies and contestations. And analyzing these uncertainties, leads to some interesting empirical work. And a possible practical strategy to do that may involve what Muniesa here and Linard called trials of explicitness, which is basically translates into a kind of interest, all right, empirical interest in the very mundane circumstances in which explanations of what is going on, okay, become visible and researchable. I'm going to provide an example of that, which is from some work that I've done with others on learning analytics, in the idea of personalization in learning analytics. Personalization in learning analytics is one of the main promises, right, of artificial intelligence in education. It refers to the use of data and predictive modeling to support students, customizing the learning experience to cater to their needs and motivation. So the question is, how does one research this topic as a distributed sort of system, a collection of trials of explicitness? And I think this can be done in a number of ways, right? And sort of paying attention to a number of empirical scenarios. For example, you could pay attention to how individual platforms or digital infrastructure projects explain the generation and the analysis of student data in their official communication and documentation. So looking for explanations in that particular body of evidence. Then you could look at the disciplinary literature on, again, data science and the related kind of discourses or talks, interviews, scholarly event, where computational methods in education are described and discussed. So different methods, supervised, unsupervised, decision trees, neural networks, and how each of these methods come with different assumptions and different contestations between experts. So a study could sort of examine how basically these explanations are put together in the disciplinary communities and how predictive performance of these algorithms is framed as an explanatory device. Then you could also look at how learning designers, programmers, again, developers, artificial intelligence experts, learning analytics experts explain the interface between computation and theories of learning that underpin personalization. The key point here is that personalization algorithms in education never operate in a complete theoretical vacuum. Even when learning theories are not explicitly acknowledged, there is always underlying implicit theories that sort of inform the grammar of action of the system. And these are often about individual agency, responsibility. For example, in many personalized learning systems, learning is implicitly conceptualized as a binary, an individualistic pursuit. So a lone student either knows something or doesn't. And there are no degrees. And learning can only develop along a predefined path of prerequisite achievements that leads to expected next steps, without divergences except those allowed by design. Yeah, and in some cases, this type of learning explicitly reflects the pass-fail binary, of testing, as it happens in many of these systems. And yeah, finally, you could look at how explanations of the value of educational data are sort of expressed, articulated at the level of governance, okay, political and economic. And here you could investigate how institutions or commercial entities explain their needs for ever larger volumes of data. So how technology companies do that, but also how public or private actors, how the kind of sort of actors in sort of networks of universities and government bodies developing education policies. So again, looking at the trials of explicitness that happen at different levels gives you some interesting empirical material that then you can use to tell interesting stories, right? That support some of those claims that I was referring to earlier. And it also allows you to ask other kind of questions, related questions that allow you perhaps to expand a bit more the scope of your inquiry. For example, in my specific case, I'm mobilizing this kind of methodological sort of approach to ask a very specific question around educational labor. So how is that changing? How is educational labor changing as a result of automation and the result of artificial intelligence coming into education? So yeah, this is a kind of working thesis that I'm currently exploring in my research. And is that human sense-making is still the primary source of value creation in these kind of processes. And this can be applied to all instances of human AI interactions, including those, for example, with generative AI that we are seeing lately. Even in those circumstances, we can see that the users, are increasingly required to engage with the outputs of artificial intelligence by filling gaps in meaning and context, revising and adapting sort of recommendations. So there are new stipulations as artificial intelligence comes into daily practices, into the daily practices of education. Then there is this new immaterial stipulations which are made. Yeah, to interpret, fill gaps in meaning, moderate content, make sure that it's not biased, there is accurate, there is not hallucinating, and so on. And this is an interesting, I believe, change in the nature of pedagogical work, in the nature of educational work that I'm trying to explore in my research. Yeah, with that, I conclude my talk. Just a little selfish plug here that a lot of this work is going to converge into a book that I'm working on right now and hopefully will come out next year. So yeah, based obviously on research that I've been doing over the past few years around these problematics. And with that, yeah, thank you for your attention. I'm going to stop sharing my slides and open for questions.
Thanks very much, Carlo, for this great talk on how to research artificial intelligence in education and how to understand it. We have a question here from Lee Harvey. Lee, would you like to come in and ask your question? And Carlo, if you could stop sharing your slides.
Yeah, there you go. Exactly. Oh, I thought I did, but clearly made a mistake there. Sorry. All right. So Lee Harvey.
Yeah. Okay, he can't activate the microphone, so I will read out loud the question. So, Carlo, you talk about peering into the black box, but Lee would like to know in rather more detail what goes on in the black box. So, what are the implications for the development of knowledge and the role of human input in that development? So, in short, is AI creating self-perpetuating knowledge at the expense of critique and deconstruction?
Yeah, okay. No, that's a very big question. Thank you very much. It's it goes really to the heart of many of the things that I was saying, and there is definitely an argument that could be made about artificial intelligence, especially the kind of current paradigm of artificial intelligence, even what we're observing in generative AI, so the latest, most advanced form of forms of artificial intelligence that we have. Even in those cases, we are sort of working with the same paradigm, which is that based on the idea that the past fundamentally, shapes the future, right? Which is something that has been noted many times before, and it's something that needs to be reiterated. It's the idea that even when artificial intelligence becomes extremely good at sort of recomposing, rearranging language, which is considered one quintessentially human, communicative ability, right? Even in that case, it is impossible for artificial intelligence to go beyond basically the limit of the training data that was used for its training, that was used for its development. And so that is something that is fairly, I suppose, it's non-controversial. I mean, it's part of the operational logic of artificial intelligence, and it's a limit that is often acknowledged also by those who develop these systems, at least in some circles. What the problem is that we have a tendency also to project anthropomorphic qualities on these systems, especially when the simulation of communicative competence is so accurate and so effective. And that is another problem that complicates matters even further, because it becomes then even more difficult to illustrate how the limits in these systems are so ingrained and that they cannot be easily overcome, even when their performance is so impressive. And my personal worry is that our progressive entanglement with this system, on account of the efficiencies that they certainly offer, will lead to a reduction in our ability to engage critically with knowledge and with the world around us. This is certainly something that worries me. Obviously, these are also very how can I say, abstract concerns, perhaps. There are also very, very material, very urgent and in the here and now issues associated with these systems, and the fact that they tend to reproduce a number of structural problems. The fact that the harms, right, that they they tend to reproduce are very much real. The fact that they are extractive technologies that require huge amounts of power to run, the fact that they constantly require human labor, in order to function in a certain way, to even generative AI and ChatGPT, they depend on basically human workers interacting with the reinforcement process in order to quite literally tweak the system to reduce kind of its harmful tendencies. So these are very real issues, aside from the more kind of perhaps abstract concerns, which are still important. But just wanted to make sure that also those very tangible things are taken into account when we talk about artificial intelligence.
Great, thank you, Carlo. So I was asked to read out loud the next question from Muhibuddin. So as artificial intelligence systems are increasingly being used to make decisions that have significant impact on people's lives, and if AI systems are biased, how do they lead to unfair or discriminatory outcomes? So what's the relation between the outcomes and the AI input?
There are many. There are many instances where basically biased algorithms can lead to harmful sort of consequences for in education. The classic example, perhaps extreme at this point, is when performance in standardized tests, which is notoriously correlated with socio-demographic aspects, is used as a predictor or a factor, in the training process, and that ends up reproducing this sort of dynamics, the problematic dynamics that we've seen in education for a long time. So the risk is basically when the known structures of education and the various inequalities, the tendency to reproduce certain forms of advantage, right? All of these things then are implicitly sort of through the training data that goes into algorithm end up reproducing the same problems, right? So another example, perhaps a bit more related to discussion of learning analytics, is when learning analytics are claimed to be colorblind. All right, so it is possible to develop learning analytics systems in such a way that elements of racial elements, and other kind of markers of ethnicity are obfuscated or kept hidden from you, if you like. And this obviously comes with a certain assumption that it is possible to completely eliminate these factors, creating artificial conditions which do not reflect the actual conditions of inequality, and so they basically reproduce a fallacious notion, an artificial notion of equality that does not recognize the various structural conditions that cause or determine those problems. And as a result, they simply place emphasis on individual performance completely sort of disregarding those factors. So it's basically the short answer to that is that the main problem is that when the various issues and problems and the structural kind of problems that we have in societies get reproduced in these systems, and as a result, basically what comes out from the other end, right, is basically a reinforcement of the status quo.
Okay. Well, thanks, Carlo. The next on the list is Jenny, but it seems that there's trouble with connection, so they will leave and rejoin. So I will ask Tina first. Tina, if you can ask your question. Okay, Tina Crow. Right.
Maybe it's in the chat.
Okay.
No.
No, it was written directly to me. So I will read it then. So the question is it possible to pre-train large language models with, for example, equality frameworks to minimize discriminatory bias? Or is this too complex an issue for the current systems?
In principle, that is possible, but there are several issues with that. The one that I can think of is the fact that these systems are dependent on large volumes of data, and whether it is possible to curate data in such a way that these issues are completely eliminated. It's an open question. I'm not sure that is possible, even desirable, to be honest. The question, I suppose, that I would like to ask is that what would be the purpose of developing a language model based on that assumption? The question is, I suppose, is at a higher level, is that why would we want a system that can simulate communicative competence, in the first place? I suppose that is a question that I'm not sure we have an answer to. But yeah, in principle, I think that is absolutely possible.
Okay, thanks. So from Jenny or Yanni, I'll just read the question myself. I'm not sure what's happening there. So do you think the propensity for AI to hallucinate will create a new category of new knowledge?
I think that the propensity of AI to hallucinate, it's mainly an issue it's mainly a threat to our frameworks of it undermines generally trust, and it's an issue that I don't see that as leading to new forms of knowledge, unless perhaps you're referring to the possibility of hallucinations being almost like a creative stimulus. And there is some interesting work in computational creativity, where basically the hallucinations of AI, either sort of visual or textual, can be considered as are used basically as a stimulus to sort of assist the creative process, or quite literally, the hallucinating AI is recruited as a partner in that process. So there is a kind of co-creation sort of process going on there. So in that regard, there are, I suppose, interesting possibilities which are fairly kind of confined, to the area of creativity and creative expression, I suppose. But in my work, I'm more concerned about the kind of issues that raises in terms of the educational process, in terms of how these systems are being used by I imagine students who are not equipped with the kind of epistemological resources to identify, to recognize the hallucinations and evaluate them, accordingly. So that is an issue that I'm personally worried about.
Okay, thanks. So I think I'll ask a question here. It might be the last. There's comments for thanking you to answering some difficult questions so well. So my question might be the last one, but I thought it would be quite interesting and useful, Carlo, if you share what is your view about the notion of political, right? So how do you understand that AI is political and the computational abstractions are political, and having a political approach to research? How do you understand these different notions of what do we mean with political in these different instances?
Yeah, no, that's, again, I guess it's a great question. The way I understand political in this context, there is, I suppose it comes down to levels of analysis. There are the kind of the politics of the politics of the training data. Okay, that's one level. The fact that there are structures of power that are reproduced in the data, the fact that there is no such thing as raw data, but data is always sort of the product of political kind of processes of generation and transformation, and so there is politics in the generation of data, in the transformation of data, and in how the data is then used to train these systems. So there's that level of analysis, that level of political kind of so dynamics going on. Then there is the politics of expertise. Okay, there's another area, another kind of level of analysis that is interesting, I think empirically and conceptually. And by that I'm referring to the contestations that sort of happen in relation to expertise, in relation to how knowledge is given legitimacy and authority, in relation to who is given indeed the privilege to make claims, to sort of legitimate a particular type of paradigm to artificial intelligence, and the way this kind of politics are entwined with the political economies, right? So that we are going on a kind of broader level of the artificial intelligence industry, technology industry, and so that touches then on issues of monopolies, of the technology industry, and the interests of technology companies, and the stake that, again, for example, in this case, higher education institutions have in this process. So the fact that they are not necessarily, pawns in this process, but actively, sort of intervening and liaising, negotiating with technological corporations, actors, in order to pursue a particular vision or a particular kind of self-interest. So there is that as well. So I think thinking in terms of levels of analysis is a good way think about politics. Yeah, I don't know if that answers the question, but that's how I'm thinking about politics in relation to this particular type of work.
Great, thank you, Carlo. So there's also a comment from Victorita, which is a great comment, but since we're approaching to the end, I'm not taking any more speakers. So, well, thank you so much, Carlo. That was a fantastic talk and the Q&A session and discussion about researching AI. I really appreciate it, and thank you for staying up with us so late at night in Australia. Just before I let you all go, to say that we have 3 more webinars to go in this series on AI in higher education. So on Thursday, we have Michael Webb from JISC, which is the British agency supporting universities in digitalization, who will quite practically present how JISC supports universities with around AI. And then next week, we have speakers about AI and academic labor, and then we conclude with ChatGPT and generative AI in the sector. So thank you again, Carlo. Really appreciate your input.
Pleasure. Thank you, Janja, for having me. Thank you, everyone, for your attention. I hope I've alienated everyone with. So yeah, it was an absolute pleasure to be here. Thanks.